Hello guys, good morning and welcome back to our class in ESci123, your statics of rigid bodies. And on our last week, we have dealt with our fourth module, which was about rigid body equilibrium. So we are already done with using equilibrium equations, and now we will apply those concepts that we have learned in the actual setting. And for this module now, we are on our fifth module, and this is entitled as your structural analysis. And we will first be talking about simple trusses. So we have to apply our knowledge on equilibrium with these trusses that we are familiar of. And I think you are familiar with what our trusses are, right? So, for our objectives for this lesson, first is that you should be able to understand what are simple trusses. And second is that you should also be able to solve for the internal forces of each members of the truss. Why is it important? Because it is included with the design of your trusses, on how big or how small the dimensions of your trusses are, especially on what kind of loads it should be carrying with. Okay? So, now, what are trusses? So basically, you already knew that trusses are those structural members that carry your atop or unsa pa man. So, basically, trusses also are those structural members that support your bridges. Dili ka ng bridges nga naa sa ato dere, but ka ng dagko nga mga bridges, they have trusses there. So let us define trusses. So a truss daw is a structure that is composed of slender members that are joined together at their endpoints. So let's have a planar truss. Okay, so this is your planar truss, and basically this one is applied to your roof, right? And if we're going to look at your roof in 3D, mani siya usually ang itsura. Okay? And for example, maukontahin ni siya sa first. Yan na. Okay? And now, kibawta nga ang kaning atong truss gitabunan ni siya og kaning atong roofing material or kanang atong sin, di ba? And before siya nakatouch dira sa atong roof truss, naantay gitawag dira nga purlin. And then kung ato natanaw ang atong purlin dire, mo ni ang atong purlin. Na mura na siya og beam pero na siya sa atong roof truss. And usually mao nang nag-connect sa atong mga triangles. Okay? So, mo ni atong purlin. Kana. And kana. Okay? And so, ang atong purlin naka-connect siya diri sa atong truss, and then atong atop naka-connect siya dira sa atong purlin. So, yung ana lang ng atong atop. So basically, ang load sa imong atop, diha siya nakaigo sa atong purlin. Okay? And dira tama ka kita sa mga loads nga gi-carry diri sa atong truss. And ang atong goal, mao ni atong pangitaon nga mga forces, ato tan-awon kung unsa ang ilang makaya lang nga load nga i-carry aning atong mga structural members. So this is one structural member, another structural member, another member, another member, another, and another member. Okay? So kaning mga segments, these are what you call joints. Kaning kung asa sila nag-connect, mao nang atong mga gipangtawag nga joints. This is a joint, this is a joint, this is a joint. Then all those points kung asa na sila nag-intersect, those are joints. Okay? Sige. So, another situation mong tan-awon diri sa atong bridges. And I think this is not familiar sa atong mga bridges diri sa well, for dagko nga bridges siguro. Dili ko happy sa ko drawing ha, but this is your bridge. Asa man naka-bridge ani. So, mao ni ang atong kalsada. Yeah, mao ni atong bridge. Okay? And then, kani atong bridge, nani siya ang floor sa atong bridge, mao na atong gitawag nga deck. Okay? So, diha mo tamak ang atong mga sakyanan, diha sa atong deck. Okay? Now, ang kanang atong deck, nakakontak na siya diha sa atong strangers. Unsa naman po ng strangers? So, mao ni atong mga strangers. Mao na atong gitawag nga kanang dili nato kaila. Strangers. So, mao na atong gitawag nga strangers. Okay? And, ang kanang atong strangers, mao ni atong strangers sa mao ng mga along sa atong karsada. Ang kanang atong strangers pod, naka-connect na siya diha sa atong floor beams. So, mao ni atong floor beams. Mao ni kaning naka-against sa direction sa atong padagan. Okay? So, basically, ang atong mga loads na-locate na sila diri sa atong mga joints. Kaya nga naman, naa-diri sa atong figure, diha nato gipangbutang ang atong mga floor beams dira sa atong joints. So, ang atong truss ug ang atong loads, diha sila nakakontak dira sa atong floor beams. Okay, again, ang atong duct, which is ang tamakanan sa atong sakyanan, nakakonect sa stringer, and then ang atong stringer, nakakonect siya diha sa atong floor beams, and ang atong floor beams, diha siya nakakonect sa atong truss. Okay? So, basically, diri sa atong ends, kay diri man siya nakakonect sa ground, so, siya ang mo support. Okay? So, this is your free body diagram sa atong bridge. Okay? So, now, ang atong gyapon goal is to determine the forces nga naaani nga mga structural members. Okay? So, mao gyapon atong goal. Now, we have these two assumptions that we should remember. Okay? Kay, our goal again is to determine all the forces of these structural members. So, we have these two assumptions. In order for us to be able to design these kinds of trusses, then you should consider this one. First assumption is that all loadings are applied at the joints. Okay, so unsa man day ng joints? So, di ba, ato ni gitawag nga joint. Ang joint gani mao nang kung asa nag-intersect ang atong mga structural members. So, this is your joint. So, if we are going to solve this kind of problem, for example, we have this joint C. So, dito sa joint C, ato tan-awon, ang ato assumption, ang atong mga forces na locate dira sa atong joint C. Ang mga forces na apply diri sa atong joint C. So, siguro A, B, D ni. So, kani siya nga force, this is your FAC. Kani nga force is your FCB. And kani nga force is FCD. Okay? And these three forces you have here, these are the forces of your members. So, FAC is the force of your member AC. Your FCB is the force of your member CB. Your FCD is the force of member CD, and etc. Okay? Second assumption is that all these members daw are connected by smooth pins. Unsay pasabutan ng smooth pins? 'Di ba? For example, mao ni atong member. Ay mao ni duha na to ka members unya. Kani sila naka-connect sila og smooth nga pin. So, pwede ni nato mainganing ana, okay? Kung makaingon tag smooth pin. So, wala siya nag-restrict sa moment. Pero ang ilang gi-restrict kay ang X and Y niya nga mga movements. Okay? Mao na itong pasabot sa smooth pin. So, all members daw are connected on a smooth pin. So, bisan mo ingon ta nga naka-connect na sila gazette plate, unsa man ang gazette plate. So, wala siya i-weld ni siya sa kanang atong plate para di siya mo ingana, pero we have to make an assumption that mo ing ana siya. Okay? And because of these two assumptions, then these members, these structural members can be considered as a two-force member. Right? Nga naman. Kaya diba? Mo ni ang atong isa ka member. Mo ni atong isa ka structural member. And then, naadiri ang atong pins. Diba? Sige, ato pa ilayo. Naadiri ang atong pins. Pero, sa actual nakakonect na sila. Now, ang atong structural member, by your law of action and reaction, kung na siya'y tension diri, himo po siyang tension dira para mo equilibrium siya. Diba? Kaya this is a two-force member. This is a member that is subjected to only two force, and that two forces are at the ends. Diba, nakahinumdum ta sa atong two-force member that ang force ana dapat opposite and along with the points of where the load is applied. So this is the points where the load is applied, and himo kag line, and then mo nang direction sa atong load. Diba? And also, by action and reaction, ang imong pin will also create a reaction out of that kuan para mo equilibrium siya. So, therefore, in this case, kung ingani ang atong direction sa atong force, this is in tension. Okay? So, kung ang imong F, sige, let's assume that this one is FAC. So, this is your FAC sa imong pin, and this is your FAC sa imong member. So, equal na sila. Kani siya, nagka-tension ni siya. Tension gyapon na siya. Anong tension man na siya? Okay, imagine ha, kung ang direction sa imong arrow is away from the pin, that is tension. Or if ang direction sa imong arrow is away from the member, that is tension. Pero, kung ang direction sa imong force is padung sa imong kuan, member, or padung sa imong joint, then this one is in compression. Okay? So, tension siya. Okay, again, take note. We assume that these forces are only applied at the joints. And if we're going to determine your FAC, then this FAC is actually the force in your member. Okay? And if in ani atong direction, that is in tension, and if in ani atong direction, that is in compression. Padong sa atong joint o pa away sa atong joint. Okay? We'll have an example later on for us to be able to understand this one more. Okay? Now, let's deal with simple trusses. Ito ni tan-aon. So, daghan na tagi pang yaw-yaw kaganiha, pero balik ta sa basic sa trusses. So, you have three members. Member 1, member 2, and member 3. Okay? And they are connected at joints. At these joints. Okay. So, kung ingani daw, usa, duha, tulo ka members, they are connected at their ends. They form a triangular truss. So this one is a triangular truss. And this is assumed to be rigid. Si pasabot ana. Kaya di ba kung maghimo kag triangle nga object, dili na nimo ma-deform. Di na nimo ma-deform into ingani siguro. Di na nimo ma-deform into other forms of the triangle. Ano man? Because here in statics of rigid bodies, when we assume that these three members are rigid, then if they are connected at the ends, then this triangle can't be deformed na. Okay? So, di siya maingani. Ingana lang dyan na siya. So, if 60 degrees ni siya, 60, kani 60, bisag, unsa pa na nga forces nga atong ipang-apply aning atong triangle, dili na siya mag-change og angle. And of course, dili po na siya mag-change og length. Okay? Kaya kung mag-change ng length, then definitely, the angle will change. Pero we assume again that our structural members are rigid in this topic, in this subject, then this triangular truss is rigid. Okay? So take note. Okay? And so there are two methods in how you can solve the members of a truss. And for this episode, we'll first learn one of the methods, because if we are going to learn the two methods in this week, then that will be a very long topic. Okay, kay kaning method na to nga i-learn karon, taas ni kay nga topic, and nindot siya nga i-separate na sa silang duha. So first method is what you call the method of joints. So when you say method of joints, so you have to go into each of the joints of the truss, and then you will analyze and identify the forces in the members that are connected at each joints. So unsa man na pagbuhat. So basically, 'di ba, we already knew that when a truss is in equilibrium, then each of the components of that truss or each of the joints of that truss is also in equilibrium. And by using that idea, we'll be able to also focus more on those joints and apply the equilibrium equations on those joints. Say for example, we have this one. We have this very simple truss. Kani siya nga truss, this is pin connected here. Okay, pin support. And on the other side is roller support. And there is a 500 Newton nga force. Gi-apply dira part. This is B. This is your A. This is your C. This is 2 meters. And this is 45 degrees. This is 2 meters. Okay? So, now, by using method of joints, and you are tasked to solve for these two members, AB and BC. So what are you going to do? When you are going to use the method of joints, then this one, this is your joint B. So ato i-draw ang free body diagram sa joint B. So di ba, this is your joint B. Ato na i-circle. And this is your 500 newtons nga force. Okay? And naa kay member AB, AB, and napod kay member diri nga BC. So this is your AB and this is your BC. This is your joint B. Okay? Now, unsa ang atong 'di ba? So we have to identify the forces in these members. So we should first make an assumption kung unsa ba sila, tension ba sila or compression. And as a standard, we usually assume sa atong mga unknown nga forces, so these are our unknown forces, ang atong AB and atong BC, we assume them to be in tension. Okay? So assume tension always. And again, once you arrived on the answer nga negative, then you can say that sayo pang imong assumption sa tension. Then, you can just simply change the direction and make it compression. Okay? So, sige. So, this is your unknown force FAB. And this is your unknown force FBC. And we all knew that this one is 45 degrees. So, how can we solve this one? So, for you to be able to solve these two unknowns, you can use the two equilibrium equations. What are those equilibrium equations? Your summation of forces along the x and the summation of forces along the y. So, if you are going to look at this one, di ba, mas nindot ko mag-solve ka una kung usa lang ka unknown. And if you are going to sum the forces along the y, what will happen? Summation of forces along the y, let's say going down ang atong positive, kay down man atong unknown, this is FAB plus FBC sine of 45, diba? Equals to 0. You have here 1 and 2 unknowns. So, it is not recommended for you to solve this one by using first your summation of forces along the y. But if you're going to use summation of forces along the x, positive dira, then you have this FBC cosine of 45 plus 500 newtons equals to 0. So in this case, you only have one unknown and you can solve for FBC here. And your FBC daw has an answer of negative 707.1 newtons. As you can see, this one is negative. So therefore, our assumption of tension here is wrong. So this one di should be going the other way. Okay? So, pwede na natin ngayon or 707.1 newtons. And take note, you should put compression. Positive and compression. So, dapat tanan natong answers aning atong trusses is positive. Okay? Positive, so di ko musugot og na negative. Positive, and then you should indicate if it is in tension or it is in compression. Okay? Take note of that. And once you already knew the answer of your kuan, of your BC, then you can also use this one. That is sa imong to solve for your AB. So this one is 707.1 newtons. And again, compression ni siya kaya na-change na atong direction. Again, ang atong compression should be going towards your joint. Kung tension siya, it should be going away from the joint. Okay? So, now for your FAB, then by substituting FBC here, and then take note, gi-change na to ang direction sa atong FBC, positive ang paubos, and then kani, negative na ni siya kaya ato gi-change ang direction. And you will get your FAB as 500 newtons. And that one is in tension. Tension siya kay positive ang answer aning FAB. Again, kung negative, then change ang sign and then change it into compression. So, yung nga na, pag-solve. So, walay labot ni pag-solve na to sa atong problem karon. So, nga lang. Pero, sige, let's continue this one. And let's solve for FAC. Always take note, ha? Positive atong answer. Positive atong answer. And then, dapat naka-indicate siya if it is in tension or it is in compression. Always take note of that. Now, let's solve for FAC. We have two options. We can use joint A or joint C. Sige, ato kitaon ng free body diagram sa duha. Okay. So, ato i-compare ang duha ka joints. Let's first draw joint A. So, this is your member BA, FAB, and this is your FAC. We already solved for our FAB as 500 newtons, so that is in tension. So, instead of putting it there, FAB, ato lang ibutang tension nga 500 newtons. And this is our FAC, which is we still don't know, so let's assume that this one is in tension. Mora ba ni ang atong mga forces? No, because we still have your pin support. Your pin support is restricting your joint on its X and Y directions. So, therefore, we can just assume nga sa atong pin, paing-ana siya o paing-ana. So, AX and, oh no. So, AY and AX. Can you solve FAC using this joint? No, because if you're going to sum the forces along the X, FAC is equal to AX. And you don't know the forces of AX and AY and FAC. You have three unknowns here. So, I would not suggest you to choose joint A. How about joint C? Okay, dirita, joint C. Dari man atong joint C, this is A, this is C. C. And we learned that this one, pila ni siya nga force? We already knew that this one is in compression, right? Sa atong pag-solve ganiha. This is your FBC. And that is 707.1 newtons. And this is our unknown. And let's assume this one as tension. This is your FAC. Napabatay laing force. We still have another force. Unsa man ang kaning atong roller support, which only restricts your y direction, your CY. Wala siya nag-restrict sa atong x because again, this is a roller support. So, can you solve FAC with this diagram? Definitely. Why? Because we have one known nga x component and one unknown nga x component. So, if we're going to... How about kung mag-y ta? Dili na necessary for us to solve for the y because we are only looking for the forces in the members. Dili, wala na ta nangita for the support reactions. Pero some problems require you to first solve for the support reactions kay mo ay pinaka-dali solvon. Okay? But in this case, ato lang ni disregard kay wala man ni siya labot sa atong pag-solve sa problem. Because we are looking for FAC. So to solve again for your FAC, all you have to do is to sum the forces along the x going that direction. Positive. Which is equal to FAC minus, kay padong siya sa right, 707.1. This is 45 degrees. So that is cosine of 45 degrees is equal to 0. So therefore, your FAC is equal to 500 newtons still. And since mo positive man na siya, so positive atong answer, then sakto atong assumption that this one is in tension. Okay? So we have now our final answer. Sa atong FAB, we knew that this one is 500 FAB, 500 tension. This one is FBC 707.1 compression, and this one is FAC 500 tension. So we have now our answers. We already solved for the internal forces of each of the members. Okay? Sayon siya pag-solve, basta katiguna mo aning atong mga angles, atong mga sine, atong mga equilibrium equation. Sayon siya i-solve, pero taas siya og solution. So, mag-take time jud sa pag-solve sa problems. And also take note, if naa kay joint nga nasayop og solve, so for example, nasayop ni mag-solve ning 707.1, then if you are going to use joint C, then automatically sayop ang imong answer sa FAC. So take note, you should correctly solve for each joint as precise as possible. Kay kung masayop ka sa isa, masayop ka sa sunod. Okay? Let's have another example. I have this truss, and we have to solve 1, 2, 3, 4, 5 members of this truss. Okay? Sige. This is 45, and this is 30. Get out. This is pin support, and this is roller support. Sige daw. So, may nato pag-solve. Una daw ta diri. This is your joint B. Okay, ato i-draw ang free body diagram sa itong joint B. You have here FAB. This is your A, B, C, D. This is your FBC. And this is your FBD. This is 3 kilonewtons. Is it possible for you to solve 3 unknowns in one go? If you're going to sum the forces on the Y, you all have 3 unknowns, right? If you sum the forces along the X, you have 2 unknowns. So, you cannot use joint B for you to be able to go through all of this. So, magpili ka og asay ninot nga joint para makasolve ka og makastart ka og solve. Because one of the techniques for you to solve unknown members of a truss, you have to select a joint that has only 2 unknown members. Okay? Take note, you should choose a joint wherein that joint only has 2 unknown members. So, you cannot choose joint B for you to solve this problem. You have to choose a joint nga solvable siya. Okay, so asa man ta makapili ana? Sir, 3 kilonewton sa maghinon nga force dira, sir. Asa man ta mapili? Diba? 3 kilonewton sa matong force. But, diba, we already knew that this one is in equilibrium. And therefore, if this one is in equilibrium, then we know that we can solve for these support reactions. Right? And it's up to you if you are going to select the right or the left. So, sige, para ikaw, asa mo kaganan mag-solve, sa right or sa left? For me, I would rather prefer to solve diri sa atong right nga joint, which is your joint C. Because we can solve for this support reaction. Diba? Okay, diba? We knew that this one, joint C nimo is supporting CY. And your joint A is supporting, don't mind sa directions na kuha, ako lang ni mga assumptions. Okay, kita man ko nga padong ang 3 dito. So, ang A ay assume nga dapat mo-oppose siya ng atong 3. So, AY and AX. You can actually solve for AX and AY. Diba? But I would rather prefer to choose CY kay usa ra man siya ka anon. Diba? And how can you solve for CY? You can solve CY by using summation of moments at point A. Diba? And assume the direction is going positive along your CY. So that is CY. Pilay distance ani okay boss distance ay. CY times 4 meters. Sunod minus kay pa-clockwise man ni siya 3 kilonewtons times 2 meters equals to 0. So therefore, you can get the value of your CY as 1.5 kilonewtons. Okay? So dito mabutang tension o compression aning atong support reaction kay support reaction ni siya. Okay? So we already determined for the support reaction sa imong CY. So adto ta sa atong joint C. So, i-draw ang free body diagram sa itong joint C. This is 45 degrees. This is 30 degrees. And this is going up. That is 1.5 kilonewtons. We still don't know this one, so we assume it to be tension. And this is what you call your FBC and your FCD. And we have two unknowns, and we only have one known force. Can we solve this one? Yes, we can solve that one. Because all we need to have is to have two equations for two unknowns. And since we have two unknowns, then this can be delegated by our two equations. So, una ta, summation of forces along the x. Going there, okay? Kuha mo sila. So, F, B, C, this is 45, that is sine 45 degrees. And then, plus FCD, this is 30 degrees. So, therefore, that is cosine of 30 degrees is equal to 0. So, this is your equation number 1. And now, let's have our summation of forces along the y going up. So, that is equal to FBC cosine of 45 degrees plus FCD sine of 30 degrees plus 1.5 kilonewtons is equal to 0. And that is your equation number 2. And by having two unknowns with two equations, then you can solve algebraically these unknowns. So, you can use that one on your calculator if you know, or you can just manually solve it. If you want to know the technique of answering this kind of algebraic problem on your calculator, then there are a lot of tutorials for you to be able to know how to use calculator to solve this one. Okay? Pero tapula naman ko, ako gana magtudlo og calculator technique, so kamo na lay pag tuon na ano caltech. Dili man ni caltech nga subject. Charot lang. Bitaw, bitapulan ko guys, pasensyahin. Okay. Sige. So, we can solve for this one by using our calculator, and you will arrive on the answer of sa atong FBC as negative 5.02 kilonewtons. So since we assume this one as tension and we arrive the answer of negative, then we can say that this one di is 5.02 kilonewtons. That is in compression. Okay? And the other one, for your FCD, you have an answer of 4.10 kilonewtons. Since this one is not negative, then we can just say that this one is in tension. Okay? So, kani pa atong na-solve. Kani, napatay tulo. So, we have solved for these two. Now, asa makaganan mo sunod? Will you choose D or will you choose B? Well, it's up to you. Because, if you are going to choose D, you have 1 and 2 unknowns. And if you're going to choose B, you also have 1 and 2 unknowns. So, ikaw na bahalaan na kung asa imong ganahan pilion, kung B ba or D, but you will still arrive on the same answer. So, sige daw. Ako, magbutang kong summary diri sa itong answers. Okay. So, para nako, ato lang ko sa joint B. Nya, kung ganahan mo sa inyong balay, you can choose point D, joint D. And if we arrive on the same answer, then congratulations to us. Pero if wala, then usa sa ato ang sayop. And ikaw yun. Charot. Ay, sige. Let's draw joint B. So this one is your 3 kilonewtons. And this one is your FCB, which is 5.02. We learned compression siya. 5.02 kilonewtons. We don't know this force, so we assume it to be tension. FBD. And this one, we still don't know, then FAB. Okay? So, we have two unknowns, then we can solve now this problem. Asa may inyong unang pilion? Inig, mag-summation of forces mo, tanawa sa ninyo ang inyong drawing. And imagine, if you are going to sum the forces along the x, pila ka book unknown. Kung mag-summation of forces along the x ka, you only have one unknown because this force has both x and y components. And this force doesn't have x component. So, usa lang ang unknown kung mag-sum ka along the x ani. Pero kung mag-summation of forces along the y ka, this one also has a y component and this one only has y component. So, duha ang imong unknown kung mag-sum ka sa y. So, unahon nimo ang usara ka unknown. Ato ka sa summation of forces along the x. Okay? So, that is FAB and this is 45. So, therefore, cosine of 45 degrees plus 5.02. This is still 45 degrees, so that is cosine of 45 degrees minus, because that is going to the right, 3 kilonewtons is equal to 0. Okay, so importante jud ang direction sa atong forces. Since we knew that this one is compression, then the direction of your force should be going towards your joint. Okay? So, take note, ana, kay kung masayop ka, ana, then wrong na kadayon. Okay. Okay? Kung nakaing ana na, then you should also include the negative sign. Pero, kung ganahan kag positive lang tanan, ganan ba tag positive lang tanan sa COVID? Sige, so, mana ato ay butang og opposite na direction. Okay? So, therefore, your FAB here is... So, your FAB has an answer of negative 0.776 kilonewtons. And since this one is negative, then let's make it positive, 0.776 kilonewtons, and that is now in compression. Okay? So we learned that this one is in compression DI. Okay? Now, let's solve for the other one. Summation of forces along the y, and atong positive, ato isundog sa direction sa atong unknown, FBD. Take note ani ha, na-compression na ni siya. So, dapat ato na i-change ang direction ana. Dapat dili ta masayo pug mga ana kay importante kayo na. So, 0.776. So, FBD minus 0.776 sine of 45 minus gapon 5.02 kilonewtons sine of 45 equals to 0. So the answer of your FBD is equal to 4.10 kilonewtons. And since this one is already positive, so we can say that this one is in tension. Ito i-update ng atong summary. So, FAB is 0.776. This is compression. FBD is 4.10 kilonewtons. Tension. So now we solve for this one and this one. So now, last. Okay. So last, you're looking for this one. And ganahan pa ka mo pila ani? Ganahan pa kag pangitaunon diri. So this is not necessary. And you only have to choose joint D for us to solve for AD. Okay? Okay, let's do this. Para mahumanata. Taas ang solusyon, no? Pero sayon ang pag-solve. Okay, let's have this one. Joint D. Okay, so this is your joint D. This is your force BD. This is your force CD. And this is your force ED. FAD, we learned that your CD is tension, and this is 4.10 kilonewtons. We learned that your BD is also tension, 4.10 kilonewtons. And since we still don't know this one, we can assume that this one is tension. So, unsa man nga equation ang imong gamiton for you to solve FAD? We can either use summation of forces along the x or summation of forces along the y. Sige, summation of forces along the x daw ta. Equals to, going there, FAD, this is 30 degrees, cosine of 30 minus 4.10 cosine of 30 degrees. And I think your FAD is also 4.10, of course, kilonewtons, and that is tension. Yeah. And if you are going to use summation of forces along the y, FAD, sine of 30 degrees minus 4.10, and then plus 4.10 sine 30 equals to 0. Then your FAD is still 4.10 kilonewtons, that is tension. And now we have completed our summary. Okay? So, this is how you solve method of joints. This is how you solve problems in identifying the forces in the members of the truss by using your method of joints. Okay? Diba sayon lang siya, pero again, taas ang problem, taas ang solution. And mao'y makapahago ang solution. Let's have a last example. Okay. We have again this truss. So for our last example, we have this truss. This truss is pin supported at its top right corner and is roller supported at its bottom left corner. And our goal again is to solve for the forces in each members of this truss. So we have here 5 members. Okay? So how are we going to solve for this one? Again, if we're going to evaluate this truss, if muuna ta diri sa joint B, which is this one, we have 1, 2, and 3 unknowns. So that is not advisable for us to use that joint because we have 3 unknowns. If dito sa joint D, we still have 3 unknowns, 1, 2, and 3. So again, that is not advisable for you. If we choose joint C, then you have your CX, CY, your BC, and your DC as your unknown. So, wala. Okay, masolve nila. But, you can solve for the CX and CY, and by using the summation of forces along the X and Y for the whole system. Diba? Or, you can solve for your AY in this portion here. So, it's up to you if you're going to choose joint C or joint A to solve this problem. But for me, I would rather choose joint A. But before I can use joint A as my first joint, we should first identify what is the unknown force on your AY. And to solve for your AY, you have to summation of moments at point C, which is this one. Okay. And then, equals to AY times 6, because this is 6. And then, minus 400 times 3. Is this positive or negative? This creates a counterclockwise direction. So this is negative 600 times 4 is equal to 0. And you will get your AY as 600 newtons. Okay, so now we have solved this one. This is 600 newtons. Okay, so solve na nato. Then we can choose joint A. So these are the forces on your joint A. This is your 600 newtons, and it is going up. And you don't know these forces. These are unknown. This is FAB, and this is FAD. Say angle ani. Is there any given angle? No. So, sama na ito pagpangita. But, hatag dira nga dimensions, oh. So, you can have your slope. This is 3. Okay, given dito 3. Okay, di ba? This is 3. And this is 4. So, that is 3, 4. And kung makakita ka ani nga slope, sa inyong mahinumduman kung ato na Pythagorean theorem, this is 3, 4, 5 nga triangle. Ano lang? Okay. Kung sa ato unahon, summation of forces along the X or Y. Ato unahon ang Y. Kaya nga naman, okay? Para ma-cancel out ng FAD and solve na nato ang Y. So, summation of forces along the Y going up is equal to FAB times 4 over 5 and then plus 600 newtons is equal to 0. So, I know this one is negative. FAB is negative 750 newtons. And since this one is negative, then we should change the sign. 750 newtons, and that is compression. Okay? Now, we can also solve for the X going there. Equals to FAD. And take note, we have changed the direction of your FAB. So, that should be going towards the point. And minus 750 times 3/5 equals to 0. So, therefore, your FAD is 450 newtons. And since this one is positive, then this is in tension. So, we solve for FAB and FAD. So, ito siya ibutang dali sa tong kilid. FAB FAB is equal to 750 newtons compression, and FAD is equal to 450 newtons tension. Okay? So, now, we are done with joint A. Asa man ta mo sunod? We can either choose joint B or joint D. Kamulay pili kung asa mo ganahan. For me, I would choose siguro joint D. So let's go to joint D. So this is the free body diagram of your joint D. 2 and 3 and 4. So this is your 600 newtons. This is your FAD, which is, we already solved as 450 newtons and tension. So this is going away from your joint. And we have two unknowns, your FBD and your FCD. So let's assume this to be in tension. FCD and FBD. Okay, and again, we knew that this one also has the same slope of the other one. So this is 3, 4, and 5. C. Let's solve this one. So unsa ang atong unahon? Summation of forces along the x or summation of forces along the y? Kung mag-summation of forces along the y ta, we have 1 and 2 unknowns. But if we are going to use summation of forces along the x, then you only have 1 unknown. So I would recommend to use summation of forces along the x. And that is going there. So FBD times 3 over 5 minus, plus the I, 450 newtons. And then we have another one minus 600 newtons. That is equal to 0, and your FBD has an answer of 250 newtons. Since this one again is positive, so therefore this is in tension. And summation of forces along the y, so going up, is equal to FCD, FCD plus, so since positive man, so di na ta mag-change of direction, 250 times 4 over 5. Sunod, mao lang, duha lang, is equal to 0. And then your FCD is equal to negative 200 newtons. And change the sign, 200 newtons, and that is compression. So to say update dere, FBD is equal to 250 newtons tension, and then your FCD is equal to 200 newtons, that is compression. So we already have solved for 1, 2, 3, 4. And kanina lang atong kuwang. So let's go to joint B for our last unknown force. So take note, importante kaayo ang pag-draw sa joint. And importante nga ma-account nimo tanan ng forces nga naa nga joint. Kaya kung sayop ang imong pagbutang sa mga forces, then masayop ang imong answer. Definitely. Okay? So you should take note of that, because that is so very, very important. Joint B. So this is your joint B. You have here, you have there, you have there, and you have there. So always, don't forget the external force of 400 newtons. Kay usahay baya, makalimtan na nato og butang. This one is unknown, so ato assume a tension, that is your FBC. And this one is your FBD, which is tension 250 newtons. This one is your FAB, which is your compression, so painga na siya, 750 newtons. And we knew that this one is 3 4, 5. And the other one is 3, 4, 5. Okay, so let's solve this one. For you to solve FBC, what are you going to use? X or Y? Of course, summation of forces along the X going there is equal to FBC plus 250 times 3/5 plus 750 times 3/5. Should we include 400? No, because it only has Y component. So there, 0. So therefore, your FBC is equal to negative 600 newtons. And to make it positive, then 600 newtons, and that is compression. So update FBC is equal to 600 newtons compression. So this is the final answer of your problem. So you have identified 1, 2, 3, 4, and 5 unknown forces. 1, 2, 3, 4, 5 forces. Okay? So ingana lang kasayon. Ingana kasayon, pero ingana siya kataas og solusyon. So daghan pag problems sa internet or sa references, then it's better for you to practice so that you'll be able to understand and to master this kind of solving. Okay? So again, the most crucial part of doing this one is to make the free body diagram for your joints. You should first know when to identify what joint you are going to choose, and you should also account all the forces that is acting on that joint for you to be able to correctly solve the problem. So as a summary for this lesson, then we already knew what are trusses. Those are triangular rigid bodies that can't be deformed when they create a triangular system. And you also knew how to solve the forces of these structural members by using our first method of solving, by using your methods of joint. And I hope that you understood on how to solve that one. And for our next meeting, we will continue. Okay, so see you on the next lesson. Peace.